So, hello everybody. Welcome you all to the AWS User Group Women in Tech, a virtual session on 9th May 2025. So, I'm so glad that we could connect. And for today's, our speaker is Ms.Rola Dali from Montreal. And she's an ML and AI architect and whose profile is very impressive. And I don't have to say, because you must have already seen her introduction in when you have registered for from the meetup page for this session. Uh, so let us hear it out from Rola herself about her introduction and her journey to AWS, and then we'll continue with the session. Before we start with the session, I would like to say that if you have any questions about the topic or about the slides, anything that Rola is explaining, you can always put it as a comment, and those comments will be either addressed at the end of the session or during the session if the question is relevant to what Rola is presenting or explaining about. So by that way, we are not deviated and honor everyone's time here. So with that introduction, so glad and grateful for your giving your time, Rola. Over to you for your introduction. Thank you.
Thank you for having me, Vijaya. So my name is Rola Dali. I don't. Can you see my screen? No. Okay. I have a slide. Can I share my screen? Okay. So I had a little slide. So who am I? My name is Rola Dali. I am a machine learning architect. Um, Currently at Tech 42, which is a consulting company that uh, deals with the U.S. AI/ML needs. I'm an academic, so I have a PhD in neuroscience and bioinformatics from McGill University. I started in the biomedical research and I moved to industry about 5 years ago now. And when I moved, I became an AWS enthusiast. So I'm an AWS community builder. I am the co-lead of the AWS Montreal user group, and I'm an AWS Golden Jacket ambassador. On a personal level, I'm a mother of two little angels, and my persistent hobby is caking. I really love cake. So that's a little bit about me. Um, so today my talk is going to be about intelligent document processing. Should we start or? Um,
Yes, Rola, I'll make your screen mainstream.
okay. So what I'm talking about today is intelligent document processing. I'll tell you a little bit what that is. I've got two systems here. I'm analyzing a document with both a predictive ML approach with Textract, and then with generative AI with Bedrock and Claude. And what I'll do is just compare and contrast the two from my own experience as to how I like these systems and what you need to look out for. So, so what is intelligent document processing in a nutshell? Well, it's really the automation of capturing extraction and data processing from documents, usually using machine learning. This is what makes it different from ADP. So automated document processing is usually the ML piece. There's a lot of use cases for this. We see a lot of different reasons why you would want to extract information from documents. Some of these use cases include document digitization, for example, because as companies move from paper-based systems to online, they need to digitize all of these documents that are currently sitting in different systems. We see a lot of use cases for document classification, for example, fraud detection and compliance. And there's a lot of different downstream systems that can be built on automated data extraction. So when you extract unstructured data from these documents and put them in a structured way, it opens up a lot of different possibilities. And so if you're on AWS, and the two main services that can help you do this are Textract or Bedrock. There are about maybe 2-3 years ago, the world made a big distinction between what we're calling today predictive ML or traditional ML, that being the supervised learning, unsupervised learning, and reinforcement learning. Those are been lumped together as predictive ML, and generative AI, which of course came into the public eye in November 2022 with ChatGPT. So the main differences, I want to contrast the main differences between these two different types of machine learning, because they do make a difference in terms of building architectures. So the main difference, the main three differences that I see is that machine learning, or predictive ML as we call it, was very custom. You train a model for doing a particular task. So these are usually very specific tasks, and it's a custom model for that task. That's not true for generative AI, which right now we have a lot of sorry, foundational models, and they do very general tasks. They are able to attack a whole variety of tasks, and so they're more general purpose. In terms of output, the output of predictive ML is often defined. If you're using a particular algorithms, its outputs are usually very defined. And when you're doing, for example, supervised learning, you know exactly what sort of output you're getting because you've trained the model to do so. The output of generative AI tends to be a little bit more open-ended and thus sometimes a bit more harder to evaluate. And the last main thing that I see is usually scale. Machine learning predictive ML models tend to be a lot smaller. Models are usually sized in the number of parameters that they have. Machine learning predictive ML models are usually in the hundreds to thousands of parameters, whereas generative AI models are usually within the millions to the billions of parameters. Sorry. So these three differences make it so that, of course, things like how do you evaluate the system changes, the cost of the system changes, how good does it do the particular task changes. So when you want to use either, you really want to evaluate both for your particular task. So what I've done here is I've built two systems, one based on Textract and one based on Bedrock. And I'll show you either, and then we can take a look at what the main differences are. Okay. So we'll start with the machine learning approach with Textract and A2I. So this is an architecture. It's a very, very simple architecture, particularly just to play with Textract and understand what it does. In this particular architecture, you upload a it's built for expense analysis. So you upload an invoice in a PDF format to an S3 bucket. It'll trigger a pathway through SQS and Lambda, which will trigger Textract, which is the most important piece in this. That Textract will take this image in the PDF and extract all of the keys in it, and it will put it in an S3 bucket, which then Lambda picks up. And if the confidence of Textract is very high, it will leave it at that. But if it's low, it'll trigger A2I. This is Amazon Augmented AI, which is the human in the loop system. So what this allows you to do is it allows you to put a human validator to check the responses. And so the human validator can edit or correct, and then it goes back to this bucket. So if you want to know a lot more about Textract and A2I specifically, what they accept, what they don't, they have a few. Textract has about 5 different APIs. I'm using the one for expenses. There's a little blog that I wrote with very specifics about things to be careful of, so you can look at that. And this is in the code. There's a code repo, and I'll show you what that code repo is, and you can deploy this. So if I go to my code repo, this is a public repository, so you'll be able to clone it and play with it. What this has is those two systems I'm going to talk about. It has a Gen AI system and a Textract A2I system. If you go to the Textract A2I system, You should be able to deploy this through Terraform. So if you follow the instructions, you just need to add your email account in the Terraform variables file and change the project name, because the S3 buckets worldwide have to be unique, and then you can deploy this. I deployed it yesterday because the our time together is short, and so I deployed it. So let me show you what this looks like. We can test it out. So this is S3 right here, and I've got two different systems. So I've called it Document Processing ML for the Textract, and Document Processing AI for the Gen AI. I'll open the Textract one for now, and you can see they're both empty. This one has an A2I results because when you connect them, it writes a file to make sure that it actually can access the bucket. So I'm going to come in and I'm going to upload a document here. I'm going to upload my test invoice PDF, and I'm going to upload it. And what's going to happen is it's going to go through this system right here, and then I'm going to find a lot of results in the S3 bucket right here. So if I do this, there we go. And so this is the raw Textract output, and then these are some outputs that the Lambda produces to pull out the keys. The Textract output is a very large JSON. It's a bit ugly, and so I've got some code in the Lambda that pulls out the very important keys from there. Now, if we go through CloudWatch, we can see that this trigger that happened created an A2I job. If I go, actually, let me see. In the Lambda, I can show you if we have a little bit more time. In the Lambda, there's a piece of code that says that the threshold has to be 90%. If it's less than 90% accurate, it triggers this A2I job. And so this has been created. And this comes to my portal. So if you go, the Terraform code that I gave you will produce an A2I system with a labeling platform, and you can go, there's very good instructions in the repo, but if you go to SageMaker AI, ground truth, labeling forces, private, you should be able to find this link here, which will bring us here. And then if I do this, oh, that's not the right one. I think I'm not. Okay, there he is. And so this is what the A2I looks like. So this is the actual document that I uploaded. And what this system does is it pulls out all of the keys. So it thinks that this is the receiver build to address. And you can see if I hover over it, it colors it in red. And there's a green here, which means that it is over 90% confident. And then if we keep going, it seems like it's not confident with these line systems. So service, it thinks that this is a service fee, 6 hours, 200, 120 in terms of amount, and so on. Now, I could change, if there was an error that it did made, I can change that and then submit it, and then it will go through the system. Okay, so that's how this system works, and I'll show you some of the outputs before we're done. I just want to show you the other system and how that one works. And so, like I said, the system deployment and demo is online, and you should feel free to play with it and test it out. So how does the Bedrock one work? Very similarly, we upload a document. This one is a PNG. And then it goes again to the bucket to a Lambda, which triggers Bedrock and triggers Claude, and then it deposits it in processed. So if we look at that system, so let me open these two. And again, this is empty and this is empty still. And so if I come in and upload a PNG, then I should be able to find my result. Okay, now I uploaded it. And now I should be able to find my results right here. Okay, and so I can show you what these two things look like. Okay, so again, please deploy both systems, play with them. It'll give you a good understanding of how they work, but let me show you what the main differences are. So the biggest difference, of course, is in the output. So this is the document that I uploaded for both systems, and this is the Bedrock output and the Textract output. Let's just open these in. So let me open some stuff here. And then going back. Okay, so let's do 3, 2, 1. Okay, so this is the document that I uploaded for both systems. And this is the output of the LLM. So it's a lot simpler. Of course, this depends on the prompt that you gave it and what, if you've given it a template to put it in. This is the template I gave it. So invoice number 2170, the date, the customer ID, and so on. It pulled quite a bit of information. I looked at all this information. It is accurate. This is the Textract output. So Textract gives you, this is not the raw Textract output. Like I said, it outputs a really big JSON with a lot of different fields. This is the code in the Lambda that pulls out the most important elements of that. What it's pulling is the label, which we call the key. So it thinks that this is the receiver bill to address. Other labels can be the vendor name, the customer number. There's a list, I think, of about 50 different keys that Textract outputs for this particular type of document. The value of the text that it pulled out, the value detection confidence. So how confident it is in the label, and then how confident it is in the text. Okay, so there's two here, the value detection confidence and the label detection confidence, and it gives you a score between 0 and 100. And then there's a bounding box. This is the location of the text on the document, which is how I was able to highlight them in red in the A2R. So what is the main difference here? Of course, this highly depends on the prompt, so it can be very different, but the most important thing, I think, is the extra metadata that you don't get from the LLM. So this idea that you get a confidence value, a p-value confidence for the key and the value, or the label and the value, is very important because it allows me to integrate A2I. I couldn't do an A2I integration with the LLM because I don't know where it thinks it went wrong so far. And the bounding box is interesting. And there's a lot of other keys in the actual Textract JSON that you can pull out. These are the ones that were interesting for my own purposes, but the metadata are definitely nice to have. So that's one main difference I find. The other is cost. So cost and throughput. So if I were to compare the two, so if I estimated about 1 million pages per month, let's say about 700 words per page, that affects the number of tokens. I did this again yesterday, and if I'm using Amazon Textract, it's going to cost me about 1,500 USD. A2I is also not cheap. You have to look at that, but again, we're not comparing that piece because it's not in the other system. But it would cost me about 1,500 for about 1 million pages a month. That's for Bedrock. It of course varies by model that you're calling, but if you call the Nova, it's going to cost you about 2,700, and if you call Claude Sonnet, 3.5 is going to cost you about 11,600 USD for the same 1 million pages. And so, in terms of cost, Bedrock Claude, for example, would be an estimated 8 times higher than Textract would cost. Throughput is also very different. Throughput of Textract is 5 to 25 TPS, depending on the region that you are calling it from. That of Bedrock is between 50 to 250 per minute. So the TPS transactions per second turns to about 300 to 1,500 per minute. And so you can see that, in a sense, the lower limit of Textract is really the upper limit of Bedrock. So you can get a lot more throughput through Textract for a lot cheaper for document design. So in conclusion, today we're in generative AI is moving very, very fast, and it can solve a lot of different problems. And there's a lot of problems that both ML and AI can solve. But you have differences in, at the very least, output, cost, and throughput that will affect your application. So when you want to solve a particular task, and you want to look at either, at the very least, look at the output, the cost, and the throughput. A SaaS model, my experience has been that a SaaS ML model is usually more specialized in what it can give you, and it's usually more affordable at the moment. I think as generative AI matures and becomes more mainstream, the cost is going to significantly drop, and it has dropped a lot in the last 2 years. But it is still, at least for this particular use case, it's still pretty expensive to solve that particular problem with Gen AI. But generative AI is because it's a general technology in terms of what it can solve and all of the problems it can handle. It is very interesting when a SaaS ML model does not exist, because to collect your own data, train a model, test it, and deploy it, it eventually becomes expensive enough that a generative AI model is going to allow you to move faster than working all of that. The other two things that are important to note is that generative AI is under so much development that the end of life for different models can be an issue. My experience has also been that ML systems or predictive ML systems are a little bit more stable at this point, because they've been on the market for a very long time. They have matured quite a bit. We're not there in generative AI. It's very powerful, but it's still maturing. And so a lot of models reach their end of life faster than predictive ML versions do. And the other thing is, when I'm talking about output, I talked about the keys that the specialization in keys and metadata that you get with a predictive ML model like Textract, but also generative. We have to look at accuracy, right? Is it accurate? Generative AI still hallucinate, and that can be an issue at times. There are ways to reduce that, of course, in a lot of ways, but you have to pay attention to what your tolerance of error is, and if hallucination can be an issue. So that's it for this particular talk. Again, the slides are online. You can download them. The code repo, like I showed, is also online. You can find me on LinkedIn. And if you are in Montreal, please join the AWS Montreal user group. Questions?
Yes, Rola. That was an amazing comparison use case where it brings us a lot of light into our understanding, and we could relate it very well. So a couple of questions before we close out. From your architecture screen, there were components like the input is document.png, and then there were Lambda to process and take these outputs, either using Textract or using SageMaker AI, using a model. So can you just at a high level talk about SQS and SNS is for notifying that the processing has been completed. So The part of SQS purpose in this.
Yes. So the part. So why SQS is right here? Is that what you?
Yeah, that's right. Yeah, just for
Yeah.
understanding.
I again, this is a very very simple system. This is not how I
Uh-huh.
would deploy the system in production. This
Okay.
is a POC to test the functionality of Textract in A2I. There are issues with the system if it's going to production, like orchestration and state and so on. But what the reason I like to add SQS is it allows one to decouple the processing from the storage, and so what that does is it allows you some control over the throughput. The other thing you can do is add SQS dead queue, dead letter queues, which will allow you to catch any problems and process them. Uh, and so that's where I usually put SQS. In terms of the SNS, it Textract very specifically needs SNS to uh, notify it. It will put everything in the bucket and you can have triggers from there. But if you want a notification system out of Textract, it needs an SNS, and it needs an SNS that has a very particular name. It has to start with a very particular um, name, which you can find in the blog. And so that's why this piece is here, is to um, notify the finishing of this particular task.
Yeah. Thank you. And the next question, I just made it visible. You're able to see.
So thanks for what is your experience in terms of output quality scanned documents? So Textract, I've been playing with Textract for about a year and a half. It is very good. My experience has been that it does a very good job. I think I ran thousands and thousands of documents. I've never seen an error. It tells you it's not very confident, but when I look, I've not seen an error yet. It
Okay.
works pretty well, even when the document is flipped over, when it's on the side, uh, when it's tilted. I tested all these use cases. It does a it does a fantastic job. I've not seen any issues. In terms of Bedrock, of course, that's a harder question to answer because Bedrock is a service that you're calling an LLM, so it would highly depend on an LLM you're calling. So you would have to compare whether you use Claude or Nova or any other LLM, what the capability of the LLM. So in terms of Bedrock itself, it doesn't have it's not Bedrock itself that we are evaluating here. It would be the LLM that we're calling. That's what we need to evaluate. Sorry, let me just connect. My battery is dying.
Yeah.
Just I am missing. Okay, maybe you can continue, but I don't know if it's going to. I have three computers here, and I can't tell
Okay.
where the charger for this particular one is, which is unusual. Okay, never mind. We can keep going. But yes, um, in terms of Bedrock, yeah, it would highly depend on the system behind. Now, Bedrock itself has a new system called Bedrock Data Automation, which is still fairly is trying to do this, and I think I can actually show you what that looks like. So actually, I have it in the. So you can try that. I didn't talk about that because uh, it's fairly new, but you this is what if you give Bedrock Data Automation the same text, it'll come out and digitize. It'll create Markdown and digitize everything, even to the tables, which is I guess is interesting. And if you look at the output of that, this is what that looks like. So again, it gives you some metadata, but more about the job and the document type, not so much about the individual uh, text pieces in there. But this is what that looks like. So I assume that's also going to get stronger with what it can do. Um, but yeah, it's still early days.
Okay.
Okay. Any other? Let me just, sorry. Any other questions?
Yes, Rola. I've just made it visible.
Sorry. A2I is for human review. Can you explain where it is sourced, where it sourced for, and how the feedback source is from the review? So the way A2I works is, if I go back to my code here, it takes a template. It needs, if you go to the blog, there's a lot of information. It needs three things. It needs a work template. So you decide the what I showed you, in terms of the interface, you write that in HTML. So that's the UI template. It needs that. This is what this looks like. And it needs a working team. So that's where who the people that are going to find this is, and a workflow. So what it you give it a definition of what it's supposed to do when it gets a job, and that's all, in this code. You can dig through it and you can look at the Lambda code that triggers it, and it's all set up, um, through. It needs access to a bucket, to be able to pull that document, and the information. Let me show you here. So functions, process. So it makes a call. You call the A2I start loop, and you give it an A2I payload and a workflow definition, which you predefined, which is in the code. This is what the A2I payload looks like for this particular thing. So I give it all of the information I want it to display, and all of the keys and confidences, and it displays it. But again, this is a combination of this particular payload, which is the backend, and the UI template that I wrote, which is the front end.
Got it. So thanks. And could you share the links for your Git repo for people to access and have more inputs from them?
Yes, so it's right here, through the QR code is okay.
Okay.
It's right here.
Yeah. Sure.
Okay.
So there are a couple of two more questions for you, Rola. Do you have time to accommodate?
Yes, I do, but I'm
Yeah.
worried about the computer turning off.
Yeah.
There's supposed to be one more charger somewhere. Let me see.
Yeah.
Okay, well, if it's in my bag, I'll get it, and then
So there is one more question from.
in the slide for document processing page for 700.
So I guess Rola is having some technical issues, and these questions will be the answers will be given in the YouTube in the comment section, so we can view from there. So thank you all for joining. I think we had a great session and inputs with relevant use cases and comparison between using it with the Textract and also with Bedrock model. So for further details and more inputs, we will share the links for Rola's blog and also about her GitHub repo so that those who are interested can take more inputs from there. Thank you very much. Thanks for joining this session.